Not so long ago, we've discussed a new discovery of the farthest galaxy in the universe, the galaxy that you're about to see in this video that I'm about to show you, and the galaxy located pretty far away, although it's more accurate to say pretty long time ago, mostly because the distances in this case kind of start to become a little bit irrelevant. As a matter of fact, this particular galaxy is so far away that even its name contains its redshift, which basically defines its distance, or as I mentioned, its age. This galaxy is known as GM-Z11, with Z11 in this case representing the redshift of 11, equivalent to the age when the universe was only about 400 million years old, and the approximate distance to this galaxy being about 32 billion light years. The reason why it's not 13.4 billion is because of the expansion of the universe. We've discussed this in some of the previous videos that might be somewhere in the description. But discovering this galaxy took quite a long time, and quite a lot of analysis and a lot of investigations. Yet now, something happened completely by accident. The scientists found something else, something even farther away, based on the relatively newly released image from the James Webb telescope. The image that only took a few hours to create, with the data and the image essentially being a kind of a test run, implying, of course, that when the James Webb telescope starts to observe objects directly and for a long time, we're going to start discovering some incredibly faraway objects, even farther away than anything we've ever seen before. And so I wanted to talk a little bit more about this new paper and the new discovery, which will hopefully highlight how incredibly powerful the James Webb telescope is compared to any other tool previously used by the scientists. So just as a reminder, this particular image, unofficially referred to as the James Webb Deep Field, only took about 12.5 hours to produce, whereas the Hubble Ultra Deep Field that you see right here took a few months to produce, and the earlier version of the image took at least 10 days. Which means that the James Webb telescope is able to capture so much more light and see so much farther away in much shorter time than any previous telescope we've had before. Which sort of makes sense, of course, because one of the main purposes for this telescope is to try to discover what the edge of the universe sort of looks like, and to try to discover these super faraway galaxies that are practically invisible in optical light. And so the scientists specifically designed this telescope in order to detect these really faraway galaxies as old as 13.8 billion years, if of course they existed back then. It should still be able to see the light from the really early universe pretty easily once it starts its observations and continuously points the mirrors in the same direction. But as you can see from this image created by NASA, James Webb telescope essentially covers a really big part of the infrared spectrum, much wider than the Spitzer telescope, and something that the Hubble was never able to do well either. And this is of course super important because a lot of these super ancient objects, the objects that very likely looked extremely bright, produced a lot of different types of starlight, and emitted a lot of different types of energy, by now had their light redshifted so much that all of this visible and even ultraviolet light became extremely redshifted and now appears to us as infrared light, with some light even reaching the microwave spectrum. Which of course means that we're not really able to see these galaxies with a typical telescope such as the Hubble telescope, but James Webb can see them really well. And more specifically, it's able to directly observe that era in the beginning of the universe, often referred to as the Dark Ages, when the stars just started forming, the galaxies started to develop, and the universe was still not particularly transparent. Something that started approximately 375,000 years after the beginning of the Big Bang expansion, but most likely ended within about 1 to 1.1 billion years. And so during that time, things were not particularly clear, and so it's actually kind of difficult to see those things and to study that particular part of the universe. But this telescope makes it slightly easier. As a matter of fact, as this recent study discovered, it makes it a lot easier. And so the scientists behind this paper, with the title 2 Remarkably Luminous Galaxy Candidates at Redshift 11 to 13 revealed by James Webb Telescope, pretty much tells us exactly what this paper is all about. First of all, it reminds us that we've only discovered one single galaxy at a redshift of over 10, when the universe was approximately 500 million years or younger. And that's of course the GN-Z11 galaxy I previously mentioned. But second of all, they're able to discover not one, but two separate galaxies at ridiculously faraway distances of redshift 11 to even redshift 13, which officially means that this galaxy is no longer the farthest ever found. It's now this tiny blob, which when zoomed in would probably look something like this, with this new galaxy referred to as GLASS-Z13. Wait, glass? Why glass? Well, it's actually the name of a survey or the early release data from the infrared imager on top of the James Webb telescope that released all of this data approximately a month ago, somewhere in mid-June of 2022. And somewhere in this data, the scientists realized that some of the really ancient, really powerful light was actually being absorbed by a lot of the neutral hydrogen that used to exist in the early universe and ended up absorbing a lot of the light that we just cannot see anymore. Nevertheless, by looking at the data from the James Webb, they were able to discover several patches where something was clearly being absorbed, some kind of ancient radiation. And because in this case the emissions that were being absorbed are very likely what's known as the Lyman alpha emissions, or the emissions of hydrogen, usually coming from extremely powerful galaxies that we've seen in a lot of different places. In this case, by using all of this data, it became possible to work out the redshift to these really far away invisible objects, with one of them being a little bit closer to us compared to the previous record holder, and one of them being super far away. The distance in this case would be about 33 billion light years away from us, with the universe being only about 300 million years old. That's actually the time when we think stars only started forming. And so naturally this represents some of the earliest universe we've ever observed. Quite a lot of mysteries here, quite a lot of uncertainties, and quite a lot of potential discoveries. And so far this data has already been confirmed by a separate team of astronomers, so it does seem to be pretty accurate. But I guess more importantly, there's already at least one surprise that seems to be coming from all of this data. In this case, this galaxy appears to be a little bit too massive, at least 1 billion masses of the Sun, possibly even more. And if the mass in this case is correct, it means that these really massive giants could have somehow formed extremely early on and could have already existed when we don't really expect these massive giants to exist. There are also clear signs of what the scientists refer to as the exponential light profile, very likely consistent with this being some kind of a disk galaxy, possibly about 5,000 light years across. Now that would be at least 20 times smaller than the Milky Way galaxy, but the fact that these tiny disks already existed so early on does create a mystery once again. With the mystery being how exactly did they form so early, and how was all of this possible even though the rest of the universe was still in a lot of chaos and we kind of expect things to be a lot more hectic. And so something clearly was driving these galaxies to grow really fast and to turn into disks pretty early on. What exactly happened here and what's guiding them is of course not a question we can answer. Maybe it's dark matter, maybe it's the mysterious cosmic web, maybe something entirely different. Either way, I'm sure we'll be talking more about this galaxy and all of these discoveries in some of the future videos, but for now I guess that's pretty much all I wanted to mention. You can find all of the relevant links in the description below, and a few more links in regards to these ancient galaxies as well. On that note, thank you for watching, subscribe, maybe share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, and maybe support this channel on Patreon by joining channel membership, or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.